All right, let's just jump right in. We're always hearing about what AI can do, right? It can write, it can make art, it can analyze just about anything. But how does it actually, think? It feels like this total black box, a complete mystery. But what if I told you the key to understanding it is hidden in a language that's thousands of years old?
That's the big question, isn't it? That's what we're going to dig into right now. We're going to peek inside that black box and look at the actual structure of how it reasons. And the answer, the real key to it all, is probably not what you're expecting.
Yep, you heard that right. Math. The way an AI builds what we call intelligence actually mirrors the exact same logical framework that mathematicians have been using for centuries to prove things. It's an absolutely incredible parallel. So let's break this whole thing down.
Okay, so first things first. Any system of logic, doesn't matter if it's in your brain or on a silicon chip, it has to start somewhere. You can't just build from nothing. You need a solid foundation of truths that you just accept.
In the world of mathematics, these starting truths are called axioms. An axiom is just a statement that's so obviously true, we don't even bother trying to prove it. It's a rule of the game we all agree on before we even start playing.
And bam! Right here is where the connection to AI just clicks into place. And AI also starts with its own set of axioms, but we usually call them assumptions or priors. It doesn't sit there and try to prove that language has structure. It just accepts that as a fundamental truth. It assumes that similar words have similar meanings. These are its starting blocks, the things it has to believe for any learning to happen at all.
All right, so we've got our foundation. But a foundation is just a slab of concrete, right? You can't live in it. You need tools. You need a framework to actually build something upwards. And in logic, the next step is to create some helper truths. And in math, that's called a lemma. A lemma isn't the final grand conclusion. It's not the big ta-da moment. It's a smaller mini proof that you figure out along the way just to make proving the really big idea a whole lot easier. Think of it like making one single solid brick that you can then use to build a giant wall. And guess what? AI is doing this constantly, especially with something like image recognition. When an AI is learning to see a cat in a photo, it doesn't just go from pixels to cat in one giant leap, no way. First, its bottom layers learn to spot simple things like edges. That's its first lemma. Then, the next layers take those edges and say, hey, I can put those together into shapes. That's another lemma. Each layer is a stepping stone, building on the last one, creating all these little helper truths on the way to the final answer.
So now for the good part. This is the payoff. We've got our axioms as the foundation, we've got our lemmas as the stepping stones, so now we can finally get to the big, important conclusions.
In math, this is the theorem. This is the mountaintop, the moment of triumph. It's a major truth, like the Pythagorean theorem, that's been rigorously proven through a whole sequence of logical steps, all resting on that solid foundation of axioms we talked about. Now here's the kicker. An AI derives its own theorems. But here's the big difference. Instead of proving them with pure logic, it learns them from data. Mountains of data. An AI might sift through millions of weather data points and come up with its own theorem. If clouds are dark, the probability of rain is really high. Nobody programmed that rule in. It's a statistical truth the AI discovered all by itself. And you know what's cool? Once you've got a really powerful theorem, you often get a few extra insights kind of for free. These are called corollaries. They're the obvious next steps, the things that just fall right out of the theorem with almost no extra work. It's the, oh, well, if that's true, then this must be true too moment. And AI? Oh, it is a corollary-making machine. Once it has locked in a learned pattern, that's its theorem, it can just effortlessly spin off new predictions. Those are its corollaries. So if its theorem is some complex stock trend it identified, its corollary is the instant prediction that a breakout is about to happen. It's just the next logical conclusion from the pattern it learned.
Okay, let's put all the pieces on the table now. We've looked at the individual parts, but when you zoom out and you see the whole process side by side, the similarity is it's undeniable. So on the math side, you've got this beautiful logical staircase. You start with a foundational axiom. You use that to build a helper lemma. That lets you prove a major theorem, which then gives you an immediate corollary. It's a clear step-by-step path. And now, here's the aha moment. An AI builds intelligence in the exact same way. It starts with an assumption. That's its axiom. It uses data to find a feature. That's its lemma. That allows it to recognize a big pattern. That's its theorem, which then lets it make a new prediction, and that's the corollary. The names are different, but the blueprint, it's identical.
And that right there, that really reveals the deepest parallel between them. Mathematics uses logic-driven reasoning. AI uses data-driven reasoning. The methods they use are totally different, for sure. But the process, the fundamental architecture of how they construct knowledge, is exactly the same. They both start with some basic assumptions, build up some intermediate truths, and then use all of that to derive these really powerful conclusions.
This one line it says it all, doesn't it? It's the perfect summary. One is a very deliberate, conscious process of logical proof. The other is this emergent process of statistical learning. But at the end of the day, they're both climbing the exact same ladder to get to their answers.
And so, that leaves us with a pretty fascinating and kind of mind-bending final question. We can trace the steps of mathematics because, well, humans built them. But AI is building its own layers, its own staircase of understanding. So if its reasoning is built on this same powerful structure, what new theorems, what new truths is it on the verge of discovering all on its own? What's the next layer going to show us?